Hello, and welcome to this algebra lesson where we're going to be finding the nth term of a linear sequence. So, finding the nth term of a linear sequence. Now, the nth term is basically a set of instructions that give you a series of numbers. For in this case, the numbers are 4, 6, 8, 10, and 12. Now, the n just refers to the position of the number in the sequence. So, for example, when n is 1, we get the first number in the sequence. When n is 2, we get the second. N is 3, third, so on, so forth. So, to start off with, we're just going to write a little table talking about the nth positions of these numbers in our sequence, okay? So, we've got the first number in the sequence, which is 4. Second number, which is 6. We've got the third, which is 8. We've got the fourth, which is 10. And we got the fifth number, which is the 12th in the sequence. Now, we need to figure out how or what set of instructions will give us the pattern to create the sequence all the way up to whatever nth term we want. The way we do that is we look at how the numbers change each time. Now, in this case, the numbers are adding 2 each time. So that's quite straightforward because all that means is the first part of our nth term is 2n, okay? Now, you've probably spotted that when n is 1 and we times it by 2, we don't get 4. We actually get 2. So what do we need to do to 2 to make it 4? Well, we need to add another 2. So that makes the nth term 2n plus 2. And if we just check with the second term, so we're going to put 2 into the equation now. 2n plus 2. Well, 2 times 2 is 4. 4 plus 2 is 6. Look at that. The second term in the sequence is actually 6. So I am happy with 2n plus 2 being the nth term for this sequence. Pause the video and copy this down. Okay, so look at the next example. This time we're finding the nth term for the numbers 4, 7, 10, 13, and 16. So again, I'm going to draw a little table where we've got the first, second, third, fourth, and fifth numbers in the sequence. The first is 4, the second is 7, 10, 13, 16. And once again, we need to figure out how these numbers are changing each time. And thankfully, it looks like we are adding 3 each time. So that means the first part of the sequence is 3n. Now again, you've probably spotted, if we use n is 1 to find the first number in the sequence, 3 times 1 gives you 3. But the actual first number in the sequence is 4. So what do we need to do to 3 to get 4? Well, we have to add 1. So that means that the nth term is 3n plus 1. But before we take that as a certainty, let's check. And we're going to put 2 into the equation, okay? So I'm going to put 2 into my new nth term formula, 3n plus 1. And 3 times 2 is 6. 6 plus 1 is 7. Look at that. The second term in the sequence is 7. So my nth term is 3n plus 1. Last example. So again, we're going to draw a little table for my first, second, third, fourth, and fifth number in the sequence. Now these numbers are 2, 5, 8, 11, and 14. Thankfully, again, the numbers increase by 3 each time. So it looks like we are looking at 3n again. But we still need to figure out what's going on over on the plus or minus part, because that sometimes, that usually is something added on the end. So if we do 3 times 1, well, 3 times 1 is 3, but we are getting to 2 somehow. Now, the way we get from 3 to 2 is taking away 1. So 3n, take away 1. Now, this is what I think the nth term is. Let's just check that a second. Let's put 2 into this nth term. So 3 times 2, take away 1. 3 times 2 is 6. 6 take away 1 is 5. And look at that. The second term in the sequence is 5. So I am happy that 3n minus 1 is my nth term for this sequence. So if I go one more example then. So again, 11, 8, 5, 2, minus 1. Now, for the first time, you've probably noticed these numbers are actually decreasing, okay? Now, while I'm writing this out, have a quick think about how you think this is going to affect the nth term start of it. I'm just writing this out now, apologies. So first, second, third, fourth, fifth. 11, 8, 5, 2, minus 1. Okay? So if you've spotted the numbers are going down, you've probably thought about the change between each number is minus 3. And a bonus mark if you correctly figured out that the start of our nth term would be minus 3n, okay? It's not always a positive number. It can be a negative, okay? This shows a decrease in sequence. But again, there's probably going to be adding or taking away something there, because if I do minus 3 times 1, that's definitely not 11. That actually gives me minus 3. But I somehow need to get to 11. Now, if I add 14, that will get me to 11. So I think my nth term for this is minus 3n plus 14. But we need to check this. So I'm going to put 2 into my new nth term. Minus 3 times 2, add 14. Now, minus 3 times 2 is minus 6. Minus 6 add 14 is 8. And when you look at that, that is our second term in our sequence. So I am happy that this number, or the nth term for the sequence, is minus 3n plus 14. Okay, so let's have a look at the main task then. So for these sequences of numbers, you need to figure out what the nth term is, okay? Pause the video and have a go at these questions. Welcome back. Next up, we've got some challenge questions. So again, with these challenges, make sure to double check how the numbers are changing each time, okay? Because it may not be constant and that may have an effect on the n part of the nth term, okay? So pause the video, have a quick go at these challenges. Welcome back. So here are the answers for the main task. And for the next 5 questions. And for the challenge questions. Now for the challenge, you probably spotted that the way the numbers increased wasn't regular. 2 to 5 is add 3, 5 to 10 is add 5, 10 to 17 is add 7. Now those numbers aren't the same, but what is the same is those numbers, 3, 5, and 7, add 2 each time. There is the constant change, okay? Now, if there is a change, if the first set of numbers don't match up, but the second row does, that normally means that you are looking at an n squared sequence, okay? So, well done if you got the challenge. Let's have a go at the checking question now, and let's see if we can apply this to the checking question, okay? So, final checking question. Find an expression that describes the following sequence. So pause the video and have a go. And remember, check how the numbers change each time. Best of luck. Welcome back. So, you've probably noticed that 6 to 9, we add 3. 9 to 14, we add 5. 14 to 21, we add 7. Now, these numbers aren't the same, so we can't quite figure out the nth term part yet, but the second level, we are adding 2 each time. So that indicates to me that I am looking at a n squared type of nth term, okay? But there may well be something going on extra on the end here. So let's do 1 squared, which gives me 1. Now the first term of my sequence is 6. So how does 1 become 6? Well, I have to add 5. So I think my nth term is n squared plus 5. But let's check with the second term of the sequence, okay? So the second term is 9. So let's see what happens when I put 2 squared plus 5 in. Now, 2 squared is 2 times 2, which is 4. And 4 plus 5 is 9. Would you look at that? That is our second term in the sequence. So I am happy that the answer to the second question is n squared plus 5. Thank you for watching. I'll see you next time. Bye now.